All right, so 1 minute break enough. So data, what is data? Now, data is this part. As I said, all the samples is the data. In fact, statistics deals mainly with this data aspects. And then we try to relate to the population through this probability theory and through this analogy principle, okay? So what do we do with data? Well, when we want to analyze, and you will learn a lot of tools how to analyze, we want to explore. So before even doing some sophisticated analysis, it's usually very useful to do the exploration study, to explore your data. So, and there are key steps in such explorations that I would recommend. They are not exhaustive, it's not a full list, but it's like a very brief guide, a one-page, one nutshell guide. So first, before you want to analyze with any data in your research outside of this course, check for or obtain the ethics approvals for the collecting and using the data. Now, for this course, you don't need this because it's already all it's academic data. So here you don't need it. But for research, often you do need it. And there are many examples of companies that used data which were not supposed to be used for certain purposes. It's usually data about individuals, and it was used for some political campaigns and so on. And then those companies got in trouble. So you have to be careful before you want to use it. You need to check your supervisors. You need to check your whether it's in your thesis, supervisor for your thesis, or your supervisors at your work, whether that data has all the ethical clearance for being used in that certain way. It could be, for example, it can be used in one way, but not in another. All right, but again, don't worry, for this course, you can use this, all the data that we provide without any concerns. Now, what you also want to do is to understand how the data was collected or constructed, whether it was a random sample or some other sample and so on. In the book, you can read a little bit more about this, and this would be more useful when you do your real research in practice in your career. Then you need to organize the data in a way that will allow to conveniently reorganize it in various ways. Sort it in certain ways, or manipulate with the data, or arrange it and so on, but with good purposes, of course. Now, another is you want to always check for outliers, whether you have those outliers, because they often can distort. We'll talk about this, how to do it in this lecture and also later. Now, you also want to present the data in ways that give insights to help you understand the phenomenon of interest that will navigate a deeper analysis and help you to state the hypothesis of interest and so on and so forth. Let's talk a little bit about type of variables, because they are the most important aspect of any model. That there are several types of variables, the categorical variables. These are variables that take values that belong to one or more categories or give categorical responses. For example, it could be male or female, or different states of a country, or different types of jobs, and so on. It could be also yes or no, or don't know type of responses. Now, there is also numerical data, numerical variables. And these variables, they're those that take numbers as their observed responses. And here they also could be discrete, 0, 1, 0, 1, 2, 3, and so on. Or they could be continuous variables. And we'll analyze, and this have implications on what kind of distributions, what kind of statistics you can use to analyze them. There's also, more recently became very popular, is a text as data variables. And they also can be analyzed in a lot of recent machine learning techniques that can be used to analyze them. Now, a few words about collecting of data. There are different types of different sources of the data. Data can be distributed by organizational individuals. It could be design experiment. This is sort of the ideal scenario when you as a scientist or researcher, design experiment the way you want, and that's often done. That's the most serious usually. Data, the most accurate, the most reliable, if it was designed well. Most of medical research is based on this kind of data, and or even requires this data before certain treatment or certain medications can be approved by the governments and so on. So usually it requires designed experiment data. There also could be in economics very, very popular survey type data. Has its own problems, but it also has some advantages over others. There's also observational data. Most of data in economics is actual observational study, and it has their own caveats, but this is the reality that often that's what the only type of data that is available to researchers. And again, the ideal is the design experiment. So when you do your research, if you have that capacity to collect data through a design experiment, that's the best. But you have to pass through all those ethical approvals and so on. So in particular, the data can be also classified in primary sources, or primary data sometimes called. This is when you collect the data yourself, from surveys or from running an experiment and so on. And this is indeed usually requires all the ethics approvals and so on. And there is secondary sources when somebody else collected the data and you then use it. Again, this still may require ethics and legal clearance before you can use it for certain purposes, especially if it has some individual data on individuals like people. Or even animals, actually, these days also often requires the ethics approvals. Now, it is not a secret that many businesses, they always collected some kind of data, processed, analyzed to enhance their decision making. And those who have the information often rule the world, they say. Maybe not the world, but their local environments or local business, they can do much better management. So it's very important to know how to collect the data, and even more important to know how to analyze the data, also depending on how it was collected. And these days, data is collected much, much more. By basically every website, right now we are through Zoom. Zoom is collecting a lot of information. I guess about a lot of things, certainly about our lecture and so on. So, there is more and more data, and that means that skills to analyze the data become more and more important. And so we have large amounts of data, and often it's called under this mysterious name, big data. So what is big data? Big data, there is actually no unique definition of what is big data, but there are some good pictures about it you can see on the internet. Basically, it's you can think of a big wave that goes much bigger than even we have here in Australia. Big waves that go over, whoever is collecting. And it's important to know how to collect it properly, how to analyze that. And usually it's a big mix of primary data and secondary data. And sometimes it's also distinguished between local data, long data. This is where we have many individuals and usually not so many variables, but many, many individuals, like maybe about country, even Australia, 25 million people, or China, more than 1 billion people. That's very, very long data. If you can imagine how long the Excel spreadsheet should be to contain all that. Now, example is tax data, for example, in any country, basically, even small countries, it's quite long. Now, there's also such notion as wide data. This is big wide data. This is where we have many variables, maybe not so many individuals, but very many variables. And often it's website collected data. Even if only 10 individuals came in, the Google collects a lot of data through all those cookies and so on about those individuals or their devices that attended the data. So it depends on the settings and so on, but there is a lot of this information that's been collected, in my understanding, from the website data. So this is example of the wide data. Now there's also long and wide data. That's most difficult to deal with because it's very long, a lot of observations, and it's also a lot of variables to deal with. Example of that is credit card data, for example. Whenever we pay for something, there's a lot of data is collected on the individuals who paid, and there are many individuals, and on all the products that they purchased, and so on, and what the features of the projects, and so on and so forth. So it's a lot of information to analyze, and learning the skills that we consider in this lecture and many other workshops that we'll consider, and many other courses, is very, very important and very useful skill. A little picture of the big data aspects. There is, as I said, there is no definition, no one definition that everybody would agree, but many agree that there are many aspects. And this, some of them, for example, the most important aspect is value. Often, most of the big data is not very valuable. And the trick is to extract some valuable information from it. On each aspect, you can read anywhere in the literature. We will not discuss this, but if you are interested, I'll give you some references about the big data. And we also have a course on big data in our school you can take later. Okay, this is example, for example, and this is the reference. A very nice website by researchers from Harvard University about how they use the big data on the United States that had this mainly long data, but it's also relatively wide data, where they try to analyze, real economic problems of how you can improve what they call the upward mobility of children in their country, regardless of their learning. So what they found is that if people were, for example, born here in this part of the United States, then they have very, very low income, and it's very hard for them to get out of there unless they move maybe somewhere here, and then they have more prosperities, more opportunities, and so on. So, this, you can read more about this in this interesting paper by Chetty and others, and also in the lecture notes of Raj Chetty at this website. I encourage you to look at it. Okay, all right. Now, a few more words about collecting of the data. Often there is, you can classify it as structured data. And this is one you usually can represent in a matrix. That's what we mainly will be working with when you will see the data that will provide you for you to do your research. But sometimes it's also unstructured data. And in fact, most of the big data is like that, where you can't even put it in one matrix because every time and every period it may be changing that matrix and so on. There's a lot of also text data, but still there are tools developed to analyze even the text data. Now, whatever the structure is, whatever the data is, there's also a very important principle called GIGO principle. Garbage in, garbage out. Indeed, no matter how good methods are, no matter how great I could be to teach you in this wonderful, interesting methods to analyze, if the data that is used with those methods is not of very good quality, then the conclusions could be not very accurate, maybe even completely wrong. So you have to be very careful and know the data well, maybe even clean for outliers and so on and so forth. This is what we call data cleaning. But what's important, whenever you clean the data, whenever you remove some outliers, it's important to clearly explain what cleaning was done. Who should be transparent. Now we'll move on. So this was mainly chapter 1 and 2. Now we'll move on to chapter 3. Let me make a short break of maybe 5 minutes. We'll restart at, let's see, at 2:46. I'll have a little bit of water, and you can also enjoy a little bit of free time. So I'll see you in about 5 minutes. Thank you.